Hi, everybody. This is our directions for Amplify, motion changes in Amplify. And it's some basics in Amplify that you're going to have to be thinking about on a lot of different of the labs that we do in Amplify. And Amplify is all about how forces interact with objects to make them accelerate. And so the first thing we need to do, we'll see some positive and negative numbers. We just need to know what those positive, negative numbers mean, and they mean something different than what you've probably experienced in math. So if I take this object, notice I can set its speed, and I have some positive numbers here and some negative numbers here, and I'm a horizontal and vertical velocity. We always use the horizontal. We always have things going from left to right. But just notice that if I choose a positive number, it basically makes these, I call them flames, but that's just to show the direction that this object is moving in. And a positive number on it is always going to have an object that is moving to the right. Basically, that's what positive numbers in Amplify mean, is moving to the right. If I choose a negative number, that just basically means moving to the left. Now, that's kind of a no-brainer. You probably wonder why you would need to know that, since the flames here show us whether it's moving to the right or the left. But we need to remember that positive numbers mean to the right, negative numbers mean to the left, because we're going to see some less simple examples of that in just a moment. Now, another thing that we want to think about is our forces. I'm going to go ahead and run this, and I'll just pause it and I'll put apply a force. Now, when I apply a force, if I apply a force this way, that means the force is being applied in the direction of the object's movement. In other words, it's kind of being pushed from behind, if you will. There's only one way that kind of a force is going to change this object's motion, and that is it's going to speed it up. No matter what, it'll make it go faster than it's going now. Again, it's like if you're on a skateboard moving slowly and somebody comes up and gives you a force or a shove from behind, you go faster. However, it's a little bit different if the force goes this way, because now a number of things could potentially happen. Again, use the skateboard example. Now we're applying a force opposite the direction of movement. So all of a sudden, if you're on your skateboard and you have a force in the opposite direction of movement against the direction you're going, now one of three things could happen. One is you could just simply slow down. If the force isn't that great, it would just slow you down, but you won't stay at the same speed. The second thing that could happen with this kind of a force is you could just stop. If somebody puts their hands on you hard enough on you're on the skateboard and they do it against your direction of motion, they could stop you. The third possibility, if they hit you with enough force, is they not only could not stop you, they could hit you and knock you backwards. Another analogy for this would be football players. If you get hit opposite your direction of force, you're going to slow down, or you're going to stop, or if you get hit hard enough, it'll move you backwards. So this would be the idea of a force that's against the direction of movement. This would be an idea of a force with the direction of movement. And of course, if we change this around and we make this a stopped object, then we can't really say it's with, against, or against the direction of movement, because we have no direction of movement. It is stopped. So now I want to talk a little bit about targets. Targets are a little trickier in terms of direction of movement. You can see this target has a speed on it. That speed is 1 centimeter per second. And if this was a problem you were doing in amplifying, you'll do a number like this. We want to put a force on this object that will accelerate it and make it go exactly 1 centimeter per second. And remember, it's not a negative number. So a positive number like this means it wants to be hit by an object going to the right, because positive always means going to the right. And if I do it correctly, the target will eat it up or swallow the object. If I do it incorrectly, the object will just keep moving right past that. So I'm going to go ahead and run this. I'm going to prepare a force, and I'll hit this with 2 clicks. and it'll move since we applied a force. And I did it exactly correct. I know that object was going 1 centimeter per second because my object swallowed it up. So targets are basically kind of a thing to check your work to see if you've done it correctly. So here's another example of these targets, but this one has a twist that the last one didn't have. The upper two are exactly the one that I just showed you. When I hit this with 2 clicks of force, that swallowed it up, meaning it made that object accelerate to 1 centimeter per second. Okay, this is the same mass object, but notice this target says negative 1 centimeter per second, while this one says positive. Remember, positive number means objects going to the right. Negative numbers mean objects going to the left. All right. So at any rate, I'm going to go ahead and I am going to prepare a force, and I am going to do on A. I know that this is going to swallow that up. It's the one I just did. And I'm going to do the same thing to this one, and I'm going to exert the force. Now notice what we should have expected, because we just saw it. That one swallowed it up, but this one did not. And it's because of that negative number. This wants to be hit with an object that's moving to the right with a 1 centimeter per second. This object wants to be one going from the left at 1 centimeter per second. And this wasn't coming from the left, it was coming from the right. So on this one, I actually have to do something different with it. On this one, I actually have to make it stop and change its direction. So I'm now going to put a force that is opposite its direction of movement. That'll make it go backwards, and now it hit it at negative 1 centimeter per second. So again, if it says positive, it has to be hit by an object that's going to the right. Negative means it has to be going with an object hitting it from the left. So this is the exact same one we're just looking at. I'm just going to make a couple of changes by dragging things around. I'm going to drag my 2 objects here and here, and I'm going to drag my targets over to the other side. Okay. And now I still want to make this. This wants to get hit with an object going 1 centimeter per second, but notice it's positive, which means the object has to be coming from this direction over here. It's got to be coming this way. This is negative, which means an object coming this way. So I'm going to go ahead and prepare a force. I'll do a force of 2 on both of them again. I'll exert the force. Notice the bottom one gets eaten up because it's coming the direction that this says, going to the left. This one has to be hit going to the right, which means I got to stop this one and make it move the other direction. So I'll prepare my force. This one I will have to stop and make move the other direction. I'll exert it. It only works when the object is coming from the correct directions. Negative ones always mean objects from the left. Positive ones always means objects moving to the right. So here's a sample of a problem you might encounter as you go through Amplify. And that is, we want to, with one application of force, we want to make this object accelerate to 5 centimeters per second. And notice it's a positive 5. And so we need to just make it start and be at 5 centimeters per second with one application of force. So I'm going to go here and I'd apply my force, and I would just hit this however many times it needed to go in order to get it to 5 centimeters per second. I'm not going to show you this, but that's what you would have to figure that out. How many, and you're just going to do that by trial and error. Now, another way this would work is A lot of them will have these already in motion. Now you've got to do the same thing. Here's where you'd have to hit run and really quickly come over and hit pause, because the minute I hit run, this is going to start moving. This is a little more complicated because we don't know how fast this is going. We know we want it to hit this going to the right at 5 centimeters per second. That means this object, we either need to speed it up a little bit or slow it down a little bit. If I speed it up, I want to hit it with a force arrow in its direction of motion. If I want to slow it down, I have to hit it against the direction of motion. But I have to do one or the other. No matter what, this has got to be sped up or slowed down. So this is the same setup that I just showed you with one really important change. This said positive 5 centimeters a second a moment ago. Now it says negative 5 centimeters per second now. Remember, negative says I want to be hit with a 5 centimeter per second object that's going to the left. So on one like this, I've actually got to do this. I've got to run it, I've got to move it past, and I have to stop it. And now I need to apply the force, because this one, I have to change its direction. If I did it where I started, last time I had to either speed it up or slow it down. But if I sped it up or slow it down, the object is still going to the right. This will not stop an object that's going to the right. It will only stop an object going to the left. So now I have to apply whatever force I think is right that will make that object both stop and move in the opposite direction. And I am just going to have to guess the amount of force to do that until I get it right. And as you do these, you'll start to see all kinds of patterns that show up, and it will get easier. The biggest frustration we see from students all the time with this particular unit is students want to know the answer right away. And that isn't how this works. It takes a lot of guessing and trials, but after you use it a while, you'll start seeing what all those things are. So from here, guys, we're going to go ahead and do this activity. You will probably want, as a matter of fact, you will certainly want to open this page up off of Schoology because it's got the colored pictures, which turn out a lot better than trying to look at these in off of a black and white. At any rate, notice it says types of motion. We've already established start, stop, speed up, slow down, change direction. And we just mentioned starting objects, stopping them, speeding up, slowing them down, all the like. So tell all the motion types that would change in these pictures. In other words, in these pictures, is this picture right here going to make it start, stop, speed up, slow down, or change direction? Some of them have more than one that it could do. This would be an example of one we could do. What will that do? So on. So all you're doing is telling what kind of motion change you would possibly get by this kind of force. Okay. And then down here, it says for all the remaining pictures, tell what motion changes would be needed to make the ball fall into the target. So in other words, on this, we're looking at for you to look at this picture and say, well, gosh, if that's standing still, it's not moving, and the target says 2 centimeters per second, are we going to need to start it, stop it, speed it up, slow it down, or change the direction? Okay, same thing with it. So that's all of these are just basically asking for the kind of motion change that will be required to make you successfully able to complete that. We're not asking you for a number of clicks or anything like that. This is whole thing is about our 5 types of motion changes: start, stop, speed up, slow down, and change directions. Thanks for watching.